Howdy, howdy, howdy. How is everybody this weekend? It's been a very long week. I have been working tirelessly on getting the new Solar Shed videos out. I don't know if you're aware of it, but is a new Solar Shed video where we are rebuilding everything. And I do mean everything, from the solar system to the panels to testing to showing you how I bought things, what my thinking was. The whole series is just going to be fantastically detailed. Um, and so I am really excited about it. It has taken a lot of time, and here I am going away this weekend to Dragon Con. I leave tomorrow morning, and I will be gone for I guess 8 days. And it's very difficult because that means that the subscribers or the members of the channel have got a special treat because all of the content for the next 10 or 12 days is already out there and you can watch all of it if you're a member. So thank you to the members, and I hope you enjoy it. I would like to see if anyone could confirm that my audio is working. Yesterday, during the recording of putting up the solar panels in the new solar shed, I knocked my camera over and broke my microphone in half. Well, I don't want to call it in half. Technically, I broke off the piece here that connects to the iPhone. As you can see, it's quite a bit broken, and it's caused me some real pickle this week because in addition to that, my camera crew couldn't make it this week. So I was on my own, and all of this happened late yesterday afternoon. So it has been a fun week. But that said, we have one of the best conversations, one of the best subject matters this week, and I have got a lineup for you to talk about solar panels the entire time. And I welcome questions on solar panels of any kind. Actually, I welcome any question all the time. They are always welcome. But this week, we're going to specifically cover solar panels in as great a detail as we possibly can. I want to go through what my thinking is when we buy them, what my thinking is and how to put them together. What is the real difference between, how do you read the labels? How do you calculate for different solar chargers? How many panels you need? What kind of connection you would set them up with? What kind of voltage? What kind of amps can they handle? All of these questions should become more and more clear as this week goes by. Now, some of the more experienced users may not find this content as appealing as others because I want to start off at a very low level and go through some of the details and then we'll cover some misconceptions too, some things that I've heard people say, and to a certain extent they're true, but that doesn't necessarily mean that they really truly affect everyone the way they're stated. Especially when it comes to solar panels, there is a lot there. So I am looking for someone to confirm the audio is working. If you could just confirm that for me. I am going to also validate that I can bring these messages up on the screen. I believe that right there should have displayed it. And so that looks like that's working. And so if someone could just confirm that my audio is working okay, then we will start to look to get started on a few of the items that are on the list. And the first item on the list is reading a solar panel's label. So what I want to do is find a couple of labels out on the internet and just kind of take a look at them and understand how they work, if I can find a few anyway. And so where we'll start is just by looking up a few of the, there we go, few of them, and just seeing if we can confirm how to read them and all that. Audi, Honda, Toyota, turn up the volume. All right, I'll take care of that. Let's see if we can turn it up just a little bit. And let's do this right about here. How does that sound? Is that any better there? All right. So I'm turning it up where it's basically right at the edge of the red line, so I'm hoping that it's not washing out at any point, but it looks like it's pretty safe, and hopefully that gets you loud enough. And let me know and just confirm. Otherwise, I'm just going to keep on going, and we're going to take a look at the first subject, which was going to be some labels. So let me see if I can hunt down, and I'm just going to share what I'm doing all the way around today. So as you can see, I can just share my computer screen here. So I'm going to just go out and see if we can hunt down. Oh, there we go. Thank you, sir. Let's just see if we can find some solar panels, pictures of label. And let's see if that works. And I should have prepared a few of these. And if I had had a little bit more time, oh, there's one right there. So let's take a look at, when you look at a solar panel, well, that didn't work. What in the world just happened? Oh, it jumped onto another screen. There we go. So when you take on a solar panel label, there's a few key things that you're looking for that I want to actually highlight for you. Let me see if I can blow this up, make this a little bit bigger here for us. All right. Well, let's just make this bigger. Where is there it is. All right. So there's a few key things that you're looking for here on solar panels. And when people will tell you how much power they generate, and that's usually the first thing that most of us talk about is how much power. Whoops, that's not exactly what I had in mind. That is a little bit big and overwrote part of what I had there. Let me just see if I can size that down a little bit. There we go. So the first thing most people look at is the solar power, and this is really pretty much when you're new to solar panels. This is pretty much what most of us see and most of us concentrate on, is how much power do they generate? Is it 240 watts? Is it 400 watts? But we really don't understand the impact of the other items on the screen. And what I probably should do here is we'll start with this solar panel, and I'll explain the solar panel, and then we'll apply this panel, what we learn from that, to an actual charge controller or two, so that you can get an idea of what kind of charge controller would match with those panels, and what you'd be looking for if you already have a charge controller and you want to know what kind of panel setup would work best for it. Because the wattage is only the maximum output, and this is a very important thing to start off with, is that the wattage of a solar panel is when the manufacturer builds the solar panel, they run a series of tests on that panel. And that test is based on the perfect scenario of if you have the angle just right and if you have the light just right. And technically, they put them on a test bed, and they put a certain amount of light at a certain distance with a certain brightness, and that determines how much the panel can generate. Now, in the real world, most of the time, you're not going to get the perfect scenario. So you have to understand that when the morning starts, and I'll just draw this out on the screen here, when the morning starts, you're going to start off at 0 down here at the bottom. And as the sun comes up and crests in the middle of the day, then you're going to start to go back down, and you're going to end at 0 at the end of the day also. So what they're saying is that that point right here at the very peak of this panel is where you can generate that 200 and what is it in this case, 240 watts. So you want to be very careful that you're not assuming that, hey, I've got a 240 watt panel, and if I get 4 of them, then I'm going to be sitting at 960 watts. That's almost 1 kilowatt an hour of power that I could generate, and then get 1 kilowatt hour of energy into my batteries. And since I only need 2 kilowatt hours, then hey, I'm done. That's not how it works, because as you can see, during this peak time of the day here, which is going to be this section right there, That's the only time you're going to get that maximum power out of that panel. Now, there are some tricks that some of the home installers, and we'll get to them later, on how they, what we call over panel. And what that means, and briefly what that means, is that if you can take in a maximum of 1,000 watts of power at one time, they'll put, let's say, 1,200 watts of power on there and extend this window, because the maximum amount of power that you can use is somewhere down in this area. And therefore, the entire time from here to here, you're sitting at that maximum. And the reason they do that is because the panels are usually a little cheaper than the charge controllers, and you just want to extend that out as much as possible. And this comes down to preference. I've had home systems that installed 12,000 watts of power for a 10,000 watt system. And I've seen DIY systems that do exactly the same thing. The solar shed right now is a perfect example of that. It's got two 250 watt panels running on it, but it's only got a 20 amp 12 volt system in it, and therefore it can only generate 240 watts of power at any time. Now, we're going to break that down and tell you how I know that. This is what is always in my mind when I first started, was kind of lacking. And with a lot of the feedback, they would give you the basics, but they wouldn't tell you how to do the actual breakdown. So let's start off by looking at this panel, and this is what you usually see is this 240 watts. This is what most of us start with, and then we try to figure out from there, well, what the heck, how do I use that? So let me point out 4 important elements that you're going to see on this solar panel card here that you're going to want to take note of when you look at a solar panel card. The first one, the wattage. That's how much power it can generate. That's always important to most of us. We want to know how much we're going to get out of it. Now let me go to the other 3 that you're not probably as familiar with, and let's take a look at them. We have rated voltage. We have output power current, and we have open circuit voltage. And then the 4th extra item that we're going to look at is going to be open circuit current. Now, some of these items are more important than other items. Some of them are used for calculating how much of a system you have. Some of them are used for nothing more than calculating what fuses you need to use in a particular case. And we'll go through fuses and when you need them and when you don't at some point today also. But these are the 4 elements that we're going to want to keep in mind throughout this entire live stream, because these are the ones we're going to refer back to. And so I'm going to take, at this point, this solar panel, and we're just going to go out to Amazon, and we're going to look up a charge controller. And then we're going to determine from that charge controller, based on these statistics, what would be the ideal, or what kind of configurations could you do? Because sometimes there's an ideal one, and sometimes there's not. Sometimes there's a range that you can get into, and you can do multiple configurations, and they're all about equal. And then some have benefits, and some have things that are going to cost you, but you need to be aware of why they're going to cost you. So let's start off by, I'm going to leave that window open so we can come back to it. And let's just run over to Amazon. And let's just look up, whoops. Oh, that's fine. I'm typing in the wrong box there. I'm thinking, why isn't my Amazon popping up? So let's just look up a charge controller. And it doesn't matter what voltage the system is, but in this particular case, let's just take a look at whatever pops up first. MPPT, charge controller, and whatever pops up, we'll go through. So we've got some Victron systems out here. This is a great example because Victron makes it very easy to understand what their units are. And then we've got a couple of other ones here. We have a power mister, and we have a Renergy, and we have this piece of junk here. Sorry about that. This piece of junk, the company name is MPPT and the charge controller isn't. This is what happens when you're new, when you buy things that don't represent what they are. This was a very frustrating for me at one point. So let's start off with the Victron device because it makes things very easy. And let's just pick this one right here. I'm going to launch a separate window so we know which device we're working with. And we're going to say this is an MPPT, and I'm going to use the whiteboard for this. And I think I've got a screen designed so I can zoom in a little closer on the whiteboard. I do. So we're going to look at an MPPT. What was that? A 100 slash, let's see, 100/30. Okay. So MPPT 100/30. So it's really important when you're looking at an MPPT to understand the devices. There's two important items that you really want to understand especially on a Victron device, but all of them it's important. But a Victron makes it very easy to identify them. Other devices, you've got to go hunt down the numbers. But I'll show you on a Victron device. The first one is, this is the max voltage. And this is the output amps. With a T, not a P, not two P's. So, and a lot of us ask, especially when we first get involved in solar, we say, well, why are these things important? And then you see all these numbers and they get very confusing because we're looking at this solar panel that we have over here. Let me just find that solar panel again. Sorry, I switched the screen and I lost my mouse. There it is. All right. So here's the solar panel. We're looking at this solar panel. I want to zoom in. There it goes. So we're looking at this solar panel here, and we're saying that on this solar panel, I don't know why that moved that way on me. Oh, I see what it's doing. Okay. So on this solar panel, if I can get this to actually stay zoomed in, how frustrating is that? There we go. All right, so on this solar panel, we are looking at, it is 30 volts, but we have two voltages, and most people are going to ask, why are there two voltages? You have the voltage, which is open circuit voltage, which is 37.6, and the second voltage is 30 volts. So these two numbers are very significant, and they both have very important reasons for being there. The first one we're going to talk about is what they call VOC, or open circuit voltage. Now, the VOC, or open circuit voltage, in order to calculate what max voltage is going into the charge controller, you're going to want to use, off of the solar panel, the open circuit voltage. Do not confuse this with the rated power voltage, and I'll explain why in a minute, but let me show you how to do the calculation, and then we'll back into why we use the open circuit voltage. So in this case, the open circuit voltage is 37.6 volts. Now, what this means is that if you connect solar panels, and I don't know if you're familiar with serial and parallel solar panels, but let me explain the basics first. Let's talk serial first. A serial solar panel means that you can connect the positive of one panel to the next panel, and this would output the volts of this one plus the volts of that one. So in this case, in order to determine how powerful two of these panels together would be for the purpose of using this MPPT charge controller, you would take the 37.6 plus 37.6 and add them together. Now, I'm going to be doing a lot of math today, so I'm going to cheat and use my calculator. But first, I'm going to go turn my phone on to where the screensaver doesn't keep taking it away, where I have to log in every time and slow you guys down. Perfect. Never. Okay. So it's on never close my screen. That means when my battery dies, you can remind me that I was going to use a calculator all day. 37.6 plus 37.6 is 75.2 volts. So that means that if I hook up two of these panels in series, it's going to have an open voltage, an open circuit voltage of 75.2 volts. Meaning if this charge controller takes a maximum of 100 volts, then this would in fact work with this MPPT for input. Now keep in mind we have two numbers here, and this is what goes into the MPPT controller, and this is what comes out of the MPPT controller. Now I need to switch that to the other screen so you guys can see that a little bit better. There we go. So this is what's coming into the MPP, and this is what's going out of the MPP. Now this allows you to, now let's run the same scenario, but this time let's find out if we can use 3 panels in series as opposed to 2. So we're going to put 3 panels next to each other, and we're going to wire them together in series, and then we're going to take the voltage that comes out, and it's going to be 37.6 times 3, 112 volts, 112.8 volts, meaning that if we took these 3 panels and connected them to this charge controller and it outputted 112 volts, it would crash the charge controller and most likely burn it out. Now, I will tell you, Victron is good equipment and they have some warnings and they'll kind of give you a little bit of a fudge factor. Don't push it. You'll burn it out and you'll be very, very disappointed with yourself once you do. So in this case, 3 series panels is too much, but 2 series panels works really well. Now, here's the thing about charge controllers that you really need to know. The Victron charge controller, most charge controllers have what they call a minimum voltage to activate or to run or to work. With a Victron charge controller, it is your battery voltage, minimum operation voltage, is your battery voltage plus 5 volts. Meaning, to understand if this is strong enough to charge our battery, we need to know what size battery we have. Now, we could clearly see that 75 volts is 5 volts over a 48 volt battery. It's more than 5 volts over a 24 volt battery, and it's more than 5 volts over a 12 volt battery. So regardless of what volt output this charge controller was, we know that it will work for that. Now, the question becomes is, did we look at the charge controller to determine what voltage it could charge? So that's where you have to know the voltage of your battery in order to determine how to configure your panels to know how to connect them to your MPPT. So let's go back over to the computer and let's take a look at this charge controller, and we can see right here in the description it highlights that it can do a 12 volt or a 24 volt system. Now, if we wanted to charge a 48 volt system, we would need to go find a different charger. But we know that this setup here will work just fine for both 12 volt and 24 volt because we are greater than 5 volts over the maximum operating voltage. And when we say 12 volt, 5 volts over, keep in mind that is 5 volts over the operating voltage of that battery, not 12 volts over its stated value. In other words, a 24 volt battery doesn't operate at 24 volts. Most of the time it operates in the 27, 20, even 28 volt range. So you need to have at least 33 volts in order for it to safely operate a 24 volt battery. And on a 12-volt battery, it's going to be operating at a 13.6, 13.7 max, somewhere around 13, 13.2 or so on a normal case. So you're looking at, you need it to be 18, 19 volts in that case. So in the case of a 12-volt battery, you could easily run one panel, or you could put two in series and run two. Now, you can also do what they call parallel. So if what we're saying here is that this MPPT can output 30 amps. Now, your voltage of your charge controller determines how much power you can put into your battery, but your battery voltage determines how much that actually is. So let me give you an example. We have a 30 amp charge controller here. I need to check which screen I'm on. I'm on the right screen. So we have a 30 amp charge controller. Now, at 12 volts, I hope you can hear me. I'm going to move this microphone over here. At 12 volts, 30 amps, whoops, times 30 is 360 watts. That means that the maximum output of this charge controller on a 12-volt system would be 360 watts. Now, I used the stated voltage, and it's not accurate what it will output. It will output 20 amps of that operating voltage at the time that it's charging. So if your battery is down at 11.5 volts, it's going to be 11.5 times 20, and or times 30. If your voltage is 13.3, it's going to be 30 times 13.3. I'm just going to use the number that is the stated voltage, and what I probably should do technically is use 13 volts here, but for argument's sake, we'll leave it at that point for now. And at any time you have a question, feel free to just put it in the thing. I am constantly watching, turning around and looking at the questions, and I'll be glad to answer any questions. Otherwise, I'm just going to keep on going forever and never stop. Now, let's say this charge controller stated that it could do both 12 and 24 volts. So it's reason to believe that a 24 volt system times 30 is going to be twice that. So it can shoot 720 watts. Now, in this example that we have here, let's dissect what we've learned so far. 3 panels is too much. 2 panels or 1 panel will work just fine. On a 1 panel scenario, you would have, with 1 panel, you would have 240 watts. With 2 panels, you would have 480 watts. Now, if you were charging a 12-volt system, you would have over-paneling sometimes is not a bad thing. We go back to that original diagram that I showed you. If I can find it. I don't know why my mouse keeps disappearing. There it is. Okay. We go back to this original diagram over here, and you'll notice that on this, can you see my mouse? Yes, you can. On this diagram, or on this chart, that we have 240 watts, meaning that if 1 panel is there, it's going to output 240 at maximum. At 2 panels, it's going to output 480, which is what we've written here. I don't remember why I was, so doing the 2 panels and getting the 480 watts and over paneling this a bit will extend that window, like we said here, to longer period of time. Will you be hitting the 360, and you don't have to go looking for 1,000 different configurations of panels to get it right at 240 so that you don't go over. A little bit of going over is okay. Many of the Victron devices and most of the, I won't say most, a few of the devices that are out nowadays have started saying how much is too much of an over panel. In other words, you can put more in. They know you can put more in there than it can output, but you're not exceeding the input voltage, so it's okay with it. Two solar companies, the manufacturers of the MPPs and stuff, have started labeling them how much you can actually do this. A good rule of thumb is I've seen good 20% is usually not even ever a problem. I haven't seen a scenario where it is. I've seen 50%. I've even seen as much as 100%, and I haven't seen too much of a problem. But I do know that this past weekend when I was hooking up the solar shed, I had a 100/20, and I hooked up 780 watts of power, and there was a sunburst at one point, and I did get a warning that there was too much power available. And I've never seen that before. I've seen too much voltage available, which is how I know Victron sometimes will save you from your own self. But I've never seen one say that there was too much power available, and that was what it did say. So you can overdo it a bit, but I would say 50% you ought to be pretty safe, and at 20% you should be absolutely safe with every device I've seen up to this point. So now let's talk about the downside to having these in series is what they call shading effect, meaning that if a big cloud comes along and shadows this one here, and the power on this one drops, it affects the output of this one here. Because like anything else, if you have two batteries and one of those batteries is weak and one of those batteries is strong, the weak battery drags down the strong battery and causes you to lose a lot of power. So nothing is different about solar panels in that extent, is that not all the power from this will make it because that one's going to be dragging it down. So a lot of people prefer to do what we call paralleling. And paralleling means that you take the same scenario of two panels, but instead of connecting them to each other in a series like this, you take the two positive wires and the two negative wires and you connect them to the same input. Now, because you've done this, they're still operating at 37.6 volts each one, and you have 37.6 volts, but what you have that changes is if you look back at this diagram that we have here, I'm sorry, I got to remember to switch my screen. So we changed it from this to paralleling, and on paralleling, lower that just a little bit so you can see it. And on paralleling, we connect the two positives and the two negatives together, and you end up with the same voltage. But what happens is the amps add together. Now, you ask, why is that important and what is significant about amps? So we look back at the original label that we have, and it says that the output amperage is 8 amps. Now, here's where things kind of get fuzzy for a lot of people. The amperage, and if you're familiar with electricity in any form, volts times amps equals watts. So if you take the 30 volts, multiply it by the 8 amps, keep in mind that we're using the rated power voltage here as opposed to the open circuit voltage. And I'll go into the difference between them in just a second. But for this calculation, we need to look at the rated power voltage. The rated power voltage times 8 is 240, I would assume. And that means that if we have two panels cooked up in parallel, that becomes from 8 amps, it now becomes 16 amps. Now 16 amps at 37.6 volts, as we just discussed, the the power that's being generated is volts times amps. And since we have 37.6 volts and 16 amps, surprisingly, or not so surprisingly, it equals the same 240 watts as putting them in series. But here's the benefit to putting them this way. The benefit is now when this one gets shaded, it doesn't affect the 8 amps coming out of this because it's just being added to that one. When that one gets shaded, it doesn't affect this one. So now they don't affect each other shading wise. Now, this on a 12 or a 24 volt system seems to me that it would be much more important to keep the panels in parallel in order to prevent shading from having as much of an effect. And you would be right. It would make sense to keep them in parallel. But let's just assume for a second, and this is where things, when you start building systems, you have to start asking yourself, what happens if I have a 48 volt system? So if I have a 48 volt system, and let's say this charge controller supported 12, 24, and 48. And to be honest with you, I'm kind of surprised it doesn't because most Victrons do. But let's go back to the whiteboard, and let's say that this supported a 12, a 24, and a 48 volt system. Now I'm going to put this in orange because we know it doesn't right now, but let's just say that it did. If it supported a 48 volt system, it would again double the amount of solar panels you could hook up to it, which would be 1,440 watts, meaning, and if this is something that you picked up on and you're asking yourself, does this mean that the same charge controller can output charge 4 times what a 12 volt charge controller can for the same price? And the answer is yes. It can output double on a 24 volt system, and it can output quadruple on a 48 volt system. And this is why it's so popular. Not only are you looking at getting the wires smaller, but your charge controllers are smaller. Now, here's where you pay the price. The price comes in when you start looking at how do you hook up the panels, because now we go back down here to hooking up these panels in parallel. Move that microphone over there so it doesn't get in the way. We start hooking these panels up in parallel, and we're running at 37.6 volts. The problem is the very first rule was we have to be the battery voltage plus 5, meaning we need to be able to go at 58 volts, which is the maximum voltage for a 48 volt battery, plus 5. We need to be able to get to at least 63 volts in order for the charge controller to properly be able to function and charge a 48 volt battery. Well, putting one of these panels in, putting these two panels in parallel will not work for a 48 volt battery. The voltage isn't high enough for it to charge it. It works just fine in a 24 volt system, and it works just fine in a 12 volt system. But I also question you is it works fine on the input of a 24 volt system, but on the output is based on how much rated power do you have, not how much open circuit power. And here's where we need to discuss the difference between open circuit and rated power. So when you connect something to an electrical, a battery, for example, if you connect a light bulb or a large load, usually what you will see is the current in that battery or that source of electricity drop. You see it in even your grid. A lot of inverters, especially the cheaper ones, you'll look at something with a meter and it will show you that the power is, that battery is, let's say, 26 volts. And you hook up a big motor to it, and it'll run the motor, but then while you're doing that, you notice that the voltage drops. The same thing is true with a solar panel. The open circuit voltage means that it's open and there's nothing connected to it, what is the total voltage that it is putting out? Then the operating rated power voltage is going to be where it is normally operating at peak efficiency. In other words, that MPP is going to go in and extract it at 30 volts as much as it can, and that's where it's going to usually find the ideal voltage that it needs to pull from that panel, and that voltage will drop down and it'll keep pulling power until it gets down to around 30, and that's where that's going to balance between how much can I pull and how much am I getting. And when you pull too hard, the amount of efficiency goes down, and when you don't pull hard enough, the efficiency goes down. So the panel is stating to you that you are going to find that its rated voltage is ideal at 30 volts. So what we want to be able to do is on the output side of this controller for these panels is we want to make sure that that ideal voltage is 5 volts bigger than the battery. So for a 24 volt battery who is most of its charging time is going to be at 26 and 27 volts, you're going to need 31, 32 volts just to get past the ideal voltage to charging, not to mention the maximum is going to be 33. Well, this one's going to have an operating voltage of 30. It's too low. So you can't really, on a 24 volt system, run these in parallel like this. You need to run them in series like this. Now, here's where things get kind of tricky. On this 24 volt, using this at a 24 volt system, you have two panels hooked up and you're getting 480 watts out of them. But it's not the maximum of 720. So what you're going to want to do in order to get to 720 is you can then take the two series of these panels and parallel the two together and come up with something that looks like this. You would have two panels in series output and two more panels in series output, and you would in turn parallel these series of panels like this. Both of these series would output 75.2 volts, but they would both also output the 240 watts, excuse me, the 480 watts, giving you a total of 960 watts coming out max, and you would have 75.2 volts at 16 amps. So if we take 75 volts times 16, 75.2 times 16, because we used that voltage, 60 times 16, we get the 960 watts. And this is where a lot of that confusion comes in as you start looking at this sticker on the back of this panel, like we have here. And you notice that you've got all these different voltages and you don't understand exactly what they're all for and why they're all there. And that's why they're there, because they all have their specific area that you're going to need that voltage in order to calculate them. So now you understand what the rated power voltage is about, the open circuit voltage is about. Now, when you go to purchase a panel, and I get this question all the time, so I want to make sure I answer it. When you go to buy used panels, and you know I'm big on finding used panels and doing crazy stuff with them, but when you go to buy used panels, you are going to want to test them somehow. Now, if you look on the sticker on the back, you'll notice that it's going to tell you what the open circuit voltage should be. Now, you can just take a basic voltmeter with you and you can hook the negative and the positive of that voltmeter on DC power, and you should get something resembling the 37.6 volts. If it's bright outside, then it should be 37.6 or really close to it. But if it's the sun's setting and it's showing 34, then you're still okay. It's not a matter of that. Now, I have found that old solar panels, one of the misconceptions in solar panels is that they get old and they degrade quite quickly, which couldn't be further from the truth. The actual average of degradation in a solar panel is less than 1% per year, meaning that after 20 years, you have less than 20%. In most cases, it's closer to 0.5%. So let's say 20 years down the road, you've degraded down to about between 10 and 20% off. Now, I've got a couple of comments here. I want to make sure that I don't ignore them before they get old. Let me just grab them real quick. Robert DIY Project says, great explanation. Some people really struggle with the configuration. That is exactly true and exactly why I decided to do this subject matter today and make sure that the panel, the questions could be answered. I have a bunch of questions that came in from online too that I'll go through later if we have time. If I don't get them, I want to give the online people a chance to ask them first. Used panels are great. I have 12 panels and 39 panels. 39 used panels, yes. And you'll notice that I am really big, and I've got a couple of videos on how I located those panels and what I did for them. And what it comes down to is I just hang out on Marketplace all day and shop them around and keep looking for them and look for people that are just trying to dump them and get rid of them. I've gotten lucky a couple of times and found solar farms that were upgrading or shutting down, and you can get them from them, and usually you can get them. The only regret I've got from that is the original solar shed was built with 12 240 or 250 watt solar panels. I don't really remember, that I got for $15 a piece. And I've only got one regret. The one regret that I have is I didn't bring a truck and get 200, 300, 400 of them and just stick them in some warehouse somewhere and either sell them or donate them or something. It was a solar farm that was closing down and didn't want them. The second time I got used panels was which is kind of a new idea that I came up with, is that I had I'd heard about somebody who had the panels taken off their roof to get a new roof, and they were just exhausted with it and didn't want to pay to have them put back on. And when they did decide to put them back on, they decided to do a rack mount in their backyard as opposed to put them on the roof because they didn't want to deal with it. But because they were going to put decided to put new panels up, and they just wanted to get rid of them. I got 29 260 watt panels for $200, $8 a piece. I still got them sitting in a warehouse and used some of them to do the solar shed update. But yeah, used solar panels are fantastic. And I didn't even have the questions up on the screen, so that should put the questions up on the screen. So yeah, used solar panels are great. It looks like you've done basically the same thing I've done. I had 12 my first time and 29 my second time. So you've got 12 and 39, so that's great. You'll be surprised how much feedback I get from people saying, oh, you can't do that, you're crazy, you're lying, you're blah, blah, blah. And they're there. They just take a lot of work to find, and a lot of people give up and go look for them, go look to buy them before they do that. 15 panels for 100 euros came from a company roofing after expanding the roof and placed new panels. There we go. Exactly the same scenario as me. Except you're over in Europe, and I hear they're a bit cheaper over there, and I don't know if it's from just they're more plentiful, or because it's government supported more, or if it's because of the tariffs or what it is, but I've heard that they are, and then I hear other people tell me that they're not. So it could go either way, I guess. Anyway, so I don't remember where we were. But the idea here is that the solar panels configuration and the and the input and the output of the MPPT is extremely important. And you can build this basically from any MPP that's out there. So I want to take a little bit more complicated variation of this and explain it. And I know that I had some specific requests to handle some of the systems that are a little bit bigger, because the solar panels in home systems get a lot larger, and they're not as small as the little one that we have here, where you have the a simple charge controller. What in the world did I do? There we go. A 100/30 charge controller. So let's look at a system that is a little bit bigger. And actually, I'm going to run over to Signature Solar, and I'm going to look us up some in one of their larger off-grid inverters. And that way we get something that's a little bit bigger and has a few extra hiccups in it for us. So let's take a look at the 12K PV. As the name implies, I believe this has 12K of PV available. And what I want is I want the spec sheet, because this is what you're going to need to look at in order to determine, and this is the same homework you would want to do to determine what any inverter is going to need to operate. Let's see if I can blow that up where we can actually read it there. And I wonder if I can. All right. So we're going to go down here, and my head is right in the way. So let me see if I can move that. I'm going to move it right off the screen. How's that? Let's just do it this way. All right. So for the purposes of this one, we are going to take a look at the specs on this and try to find the details that we would need to size a solar system for this. Now, Holland. Okay, well, you're close. I mean, it's not too far away. I'm a little bit familiar with the area over there, but not super familiar. But I know that you're not too far off. All right. So in this case, we are looking at, and you can see here that max AC input power, that's not what we need. We don't want that. We want grid. We're going to go down here to PV inputs. Here we go. This is what we're looking for. So if we look at the details here, this tells us that we have, and I'm going to find a paper towel here and see if we can clear this whiteboard off and start over building a brand new setup for it. We should probably keep the solar panel, though. Just for the fun of it, we'll keep the solar panel, since we already have the stats, and the size of the solar panel really doesn't change anything for us, other than we just got to figure out. All right, so I cleared the whiteboard, and let's take a look at some of the stats that we need from this. The first one here that I noticed that's important is that we need 2 MPPTs, meaning that it doesn't only take one input on this one, it's going to take in 2. So we're going to say that this is going to be the equivalent of having 2 charge controllers. Per input, inputs per MPPT. That's also significant, meaning that you're going to take in 2 feeds from each one. This allows you to easily parallel things. Feeds per MPPT is 2. So that now means that you've got 4 places to connect solar panels and two of them parallel together for each MPPT. Now, we still don't know the size of the MPPT controller yet. So let's go down a little bit lower. Notice that this says max usable input current. Now, this is a very specifically worded this way. Max usable input current is 25 amps per MPPT, or 41.6 total. Now, we're going to come back to this statistics, and we remember when you're talking about overpaneling, this is where it becomes very important to understand how much. Now, notice it also has a max short circuit input current, meaning it can only use up to 25 amps, but it doesn't want you to provide more than 31 amps per input circuit. Meaning, in this case, if we put almost the max, let's say we put the max on each one, 31 amps, that means that we would have 62 amps going to the charger all at one time. But if you notice, the max usable is 41. So a lot of that would still get clipped out. So we'll discuss how that affects things. Here's some important information though. DC input voltage. Now, this means that the solar panels have to provide between 100 and 600 volts of input voltage. So, how did they label that? Max DC input voltage. I'm trying to write this on the board so when we get here in a minute we have the data for it. I can show you that while I'm working on it here. So the max input voltage is between 100 and 600 volts. Now, if we continue looking down this, the unit startup voltage, you'll notice in this particular one, says that it's 100 volts. So we're going to take that startup voltage, and it is 100, what did it say? 100 volts. 100 volts. Okay. Now it's going to say if we go back to the stats, it says that the MPPT operating voltage range is, so operating voltage range is 120 volts to 500 volts. Now, a lot of people are going to ask, well, what is the difference between the input voltage and the maximum operating range? And we will get to that. I will walk you through it here. Nominal MPT voltage. Remember I said there's always a place for solar panels to give you the perfect voltage for its operation. Well, most inverters have that perfect zone also. And what you want to try to do is get as close to that operating nominal, and then they call it nominal MPPT voltage range. What it basically means is that the system's efficiency is best the closer you get to that. Now, you're not going to talk about huge losses if you're off, 10, 20, 30, 40, 50 volts. But what they're telling you is in this case that nominal voltage is 320, 360 volts. Okay. Now, what else do we have on this page? We have the maximum utilized solar power is 12,000 watts. And so I'm going to put 12,000 watts here. And the recommended maximum solar input. And here's where this is very important to recognize this. It states the recommended maximum solar input. So it doesn't put a hard limit on it. But what it does do is it gives you an idea that there is an upper window here that you should be aware of, and that it's not, it didn't come out and say, hey, look, you put more than 15,000 watts in and it's going to be causing problems. It's going to use what it needs to. But it is suggesting that the max you should put in there is about 15,000 watts. Is that a hard line? No, they didn't draw a hard line with the way they said it, because it would say maximum solar input as opposed to recommended maximum solar input. So in this case, we're just going to say recommended max is 15,000. And we can determine how much of that actually, how much of this, what it's going to take to actually generate that, as opposed to the 12,000. So now we have all of the statistics, and if I go back over here to this document, I scroll down, it's got some efficiency items here, the maximum efficiency, PV to grid, that 97.5%. That's why that nominal voltage is super important, because the closer you get to that, and the closer you get to the ideal circumstances, the better off you would be with that particular item being more efficient. So the further you get away from that, the less efficient it's going to get. All right, so let's go through some of the different configurations that we can set up for this. So let's go back to our solar panel. And on our solar panel, if I have to hunt that down again, there we go. Here it is. So on that solar panel, we have a 240 watt panel that has an operating rated voltage of 30 volts. Rated. And it has a output of 8 amps. And it has an open circuit voltage of 36 point, what was that? 37, oh, excuse me, 37.6. 37.6 open circuit. Now, the one thing that's really important to remember here is we're looking at one label. And I've noticed that a lot of these companies have a tendency to put these one labels and not use the same terminology. So I'm saying open circuit voltage and VOC, those two are pretty commonly used. But there are other ones here like rated power at STC, which basically just means the output wattage. There's a rated power voltage, VM and IM, and some of them are all very common, but they don't mean a whole lot, and they're not commonly used across all the different panels. So sometimes you have to fish through these numbers to come up with the idea of what you're looking for. Okay, so let's go to the board here and let's determine what kind of panel system we would want to configure to build the ideal string with these panels. Now, you can go out and you can go fishing for panels to fit your need. So if you wanted a 500 watt panel or a 400 watt panel, you could, but I'm going to assume that we went some solar farm shut down and they've got thousands of these and they're going to sell them to us for $1 a piece. And so we're going to build this system based on what we have available to us here. Now, all right, so let's take care of that and let's just start building it here. So we know we want to get to 360 volts of nominal voltage. This makes things very easy because we've got a rated 30 volt panel. So we could determine very quickly how many panels do we need to put in parallel to get to that, which it looks like it would be 12. And I'm just going to do the math here real quick and double check myself, but 30 times 12 gives us 360 volts. So if we took 12 12 series panels would be 30 volts times 12. That would equal 360 volts. Now, the question becomes, do you have a place where, if you remember, shading becomes extremely important on these. You don't want them facing opposite directions. You want them getting about the same sunlight. So you want, 12 panels that are in the same place, that are getting the same sun, that have the same shade, and they have very similar situations where, you might take 6 and then mount 6 more right underneath it like this. Forgive my art skills here. But we put those 12 panels like this, and then we're going to run them all in series and connect them like this together. Positive to negative, positive to negative, positive to negative, positive to negative. And we're going to have an output of a negative and a positive, and it's going to be 360 watts of rated voltage. Now we need to know what is the open circuit voltage to ensure that we are not exceeding this input voltage of 600 here. And so that's very easy to do. Very simple calculation. It's our 37.6 times 12 panels is 437.6 times 12 is 451.2 volts. So that is going to be the open circuit voltage that you would generate if you ran these 12 panels in series. Now, how much output would we get from them? Well, that's another easy calculation. That's 240 times 12, or 2,880 watts of power. So now we have 2,880 watts of power. Now, what's interesting here is we have 2 MPPTs running 2 feeds of each. So we can put 2 parallel feeds in and 2 MPPTs. Now, these panels, each of these wires coming from these panels would be only 8 amps, which that's significant in a system this size because you're talking about the distance that this is going to run. The higher you get that voltage, the less loss there is. So bringing that voltage up to 360 volts, and as you know, you can hook up a 100-foot extension cord to your home 110 or 120 volt outlet, and you can run things off of it. If you run something big, do you have problems? Yes, you might have some loss and have some issues there. But at 360 volts, you're going to have very little loss, and you're only supporting 8 amps, so you're not going to need a huge wire to support them. It would run on a normal size, 10 or 12 gauge wire, easily support this. So we're going to assume that if you've got 12,000 watts, you're going to have 6,000 watts per input to feed. And we're sitting at 2,880. Well, we're less than half of the rated thing. So what we would want to do is install a second set of panels. Now, this is assuming the goal is to try to get this as close to maxed out as we can. So this, ideally, we are in this zone of operating voltage range of 120 to 500 very easily. We are also within the input voltage range of 100 to 600 very easily. We have startup voltage at 100 volts, no problem there. We've got 360 watts of volts of panels in series hooked up. So now all we're going to be dealing with is the fact that this only generates 2,880 watts. And if it was me, what I would do is I would put a 13th panel in this series, and thus bump this up to 390 volts. Why those caps are backwards. 390 volts. But the nice thing about this is then we get this up to 3,020 watts of power. And if we did two strings like this, we get this up to 6,040 watts, being 40 watts over paneled from each of these series. So that means that we could technically put two in parallel of 13 in series, two in parallel, and this would equal 6,040 watts of power. That would be very good, and then we could actually double that and do it on the second MPPT also, using a grand total of 13 times 4, which would be 52 panels, and pulling in a 12,040 watts, nope, 12,080 watts of power, and clipping almost nothing. Now, this is where the original documentation that we looked at becomes very significant, and we have to ask ourselves, would there be any losses from any of the other caps and things that are in here? It said in that documentation, if I move that back over here, not that one, yep, this one over here, that the maximum usable input current is 41.6 amps in total. The nice thing is we are 4 strings and they're all 8 amps, and therefore we're not going to exceed 8 amps. So we should be okay there. The next thing is we are at the voltage of 340. So we wouldn't exceed anything there. Now, max short circuit, we would not be short circuiting more than 8 amps because we don't have more than 8 amps. Now, if we were putting a bunch of these serial in higher amperage, then yes, there would be a problem, or lower voltage, and then doing them together. But we're not. So we've met all of the requirements here, and I don't see any issue with how many amps we would have. So let's take the amps is 8 plus 8 is 16, would be 32. So we would be sitting at max short circuit input current, that's max short circuit input current, but that's on each MPPT. We would only be 16 at each MPPT because the two that are in parallel would in turn add together. So we would stick to the 390 volts that we have here. The 390 volts would stay, but we would have that on 4 strings, and those 4 strings would both MPTs would get 16 amps here and 16 amps here. In total, we would be at 32 amps, but we'd never be able to short circuit 32 amps. We'd only be able to short circuit 31 amps, so we'd be okay. And the maximum total usable that this had listed is the 41 amps. So in all cases, this works perfectly. Now, 13 panels is a very odd number. 13 panels is a very odd number, and it would be very difficult to find a rack that would work with 13 panels. So going back to 12 would probably be a much better setup, because then you could do 22 racks of 24 or 4 racks of 12, and you could run all the wires that way. Or you could do one rack of 48. So that is the more complex version of running this and doing it that way. You can see that we walked into the solar panels, and the inverters are kind of built or made to build out these type of things. We went from a very small 12-volt system where we were able to configure the same panels to work in the case of a huge 12,000 watt input system made for off-grid home operation. And that is the beauty of an MPPT charge controller, is that it's going to take all these high voltages and convert them all down, as opposed to the older systems that used to just clip things and you had to have solar panels that were just the right voltage and all that kind of stuff. So I hope that makes it clear on how you would configure something of this nature. And believe it or not, I had a schedule of things I was going to go through when I got started on this, and I've completely thrown away the schedule. That was the first item on my list of how to read solar panel stickers, and I think we covered that, how to read the solar panel stickers. The one part of them that we didn't cover is I want to go back to the sticker a little bit, and I'm not sure if this sticker even covers it, but I do want to go back to the sticker here and talk a little bit about weather. A lot of people don't take into account weather, and I want to kind of make sure that I have said it even if we don't cover it. Okay, so this one does. Nominal operating cell temperature at 45 degrees Celsius plus 2% Celsius. I don't know. There it is. The 25 degrees, this one doesn't come right out and say it, and unfortunately I don't have know enough to convert this. It states it here, but I don't know enough about how to convert this to the actual formula that does it. So I live in Florida, so that's my excuse for not investigating this a little bit further. But let me tell you what I do know. So what this is basically saying is there is what a lot of people have a misconception. Let me just go back to this screen here. There is a huge misconception that solar panels work better in ultraviolet light and super hot sunny days. And that couldn't be further from the truth. Solar panels work on light. And they work on light in the perfect environment where they're generating the perfect cell. They also are set at the perfect temperature. And as solar panels get hot, just like your computer or any other electrical device you have, it gets less efficient, not more efficient. But there is a warning for those of you who live in colder climates. Most solar panels, if you look down the stickers far enough and you understand them well enough, this one doesn't have a complete picture of all the different stats, and you might have to look the panel up itself, or that formula that I highlighted might actually say it to somebody who's smarter than me. Most of them have what they call an efficiency gain from each temperature below a certain point. So it may say, look, once you hit 10 degrees Celsius or 20, let's make it, let's make it 10 degrees or 0 degrees. 0 degrees Celsius or 32 degrees Fahrenheit. For every degree below that rating, there is an increase in voltage that goes along with it. So it may be a 0.3% increase for every volt under 0, or every volt under 10, or every volt under -10 that gets added on. It doesn't seem like a big thing, but when you are multiplying that times hundreds of volts and several dozen panels, it can become very significant. The best rule of thumb that I've heard that works in almost every scenario is use the 20% thing. And what I mean by 20% is we take this formula that we have here, and we know that this is going to generate 451 volts in open circuit. Now, my question becomes is, do we have a 20% buffer between this and the maximum that this system can receive? The maximum input voltage is 600 volts. 20% is 90.24 volts. So if I add 91 volts onto this, I get 540, testing my math skills here, 540 volts, which is well below the 600, meaning that this is safe to operate, or should be safe to operate. I'm not going to go so far as to say it is safe to operate. It should be safe to operate in colder climates, depending upon the temperature. So if you're in an area like, especially in Canada or some other very cold climate, you're going to want to probably find someone who knows more about this specific subject than me. I have always been able to get away with the 20% rule, and here in Florida, I don't even need the 20% rule because it never gets that cold where I am. But I wanted to highlight that and make sure that I point that out to you so that you're not caught setting up a system in Michigan or upper state New York or Washington or something like that and find out that Matt told me this was okay and it wasn't. There is an efficiency. Now this is a good thing from a certain perspective. You get more power from it because your wattage is determined by amps times volts, meaning that if your volts goes up 10 volts, then your amps stay the same, your output will increase also. So that part of it's good, but you need to be aware of that voltage change is can be very significant and cause you a lot of trouble. Okay. I did cover that. I do want to get into, we talked about series and parallel wiring, mixing panels, and what you can and can't do. Okay, so let's talk a little bit about mixing panels and what you can and can't do. There's a lot of content around this, and what a lot of the hardcore solar people will tell you is that you simply should have all the panels exactly the same size, exactly the same wattage, and blah, blah, blah. And what that basically means is we set up a system like this, and this panel goes out, and it's 5 years from now, and you have to go out and find that panel in order to put a new one in here. And that is totally not true. If you want to find a panel that is significantly close to it and that puts out, but keep in mind that it's going to drag the panel down to match the other panels. So in this case, if your panel is outputting 30 volts, 37.6 volts, and outputting 30 here, you want to make sure that it doesn't cause your open circuit to overrun you. But you also want to make sure that the rated voltage is very similar in nature, because if you put in one that's 28 volts, you could potentially drag down 11 other panels to 28 volts. So you want to make sure that you're watching that. Now, what does that mean in a situation like this? And that's would be a great question to ask, because if you take the output that you have, where we did 30 times 12 panels, let me grab this microphone over here where you can actually hear me, and we do 30 times 12 panels, and we came up with 360 volts. And then we took 360 volts times the number of amps, and we came up with the output. What happens to each of these panels when they go from 30 volts times the maximum of 8 amps, which is 240 watts of power, and all of a sudden you drag them down to 28 volts times 8, and you end up with 224 watts of power. And I don't trust that answer, so I'm going to use a calculator on it. 28 volts times 8 amps is 224 watts of power. My mind is still working at least. So if I lost 16 watts on this because I put a panel that is a tiny bit smaller, as long as I'm aware of that cost, then replacing this panel with that panel as opposed to buying all new panels would be not such a bad thing. Also, you've got to consider the age of the panels. So we're looking at a 2-point voltage drop. And the question becomes is, if the panels are 10 years old and you've got a 10% drop or a 5% drop at that point, a 10% drop would be 3 volts and a 5% drop could be 1.5 volts. So you may see some voltage drop there naturally and this panel be a perfect replacement. Or it could be that that voltage drop, and most commonly, and I find this because I like to shop around and get used solar panels, most commonly you will find that the connectors on these solar panels are what's dragging them down, and that the solar panel itself has very little degradation on it at all. Because like I said, the average is less than 1% and not more than 1%, and usually are closer to 0.5% a year. So that means after 10 years, you usually have less than 5% to 10% percentage points of degradation. So the question becomes is, can you mix and match panels like that? And with some careful calculations, you absolutely can mix and match some of them. Now, let's talk about a little bit more complicated scenario, and let's go back and look at what would happen if we built, and some of this is going to be assumptions on my part, and some of this is, and I'm sure I'll have a couple of solar gurus that will point out some of my my flaws in my thinking, and some of it is based on just pure experience from what I have done in the solar shed and what I have seen. So let's talk about mixing panels in a sense of, you have a panel, let's say we have 4 panels, and this one outputs 30 volts, this one outputs 32 volts, this one outputs 18 volts, and this one outputs 48 volts. Now, in this particular case, I would not suggest that you mix and match these panels. If you were using a 12 volt, if you were doing a 12 volt system, I would say that if you just absolutely have to have these, I would hook these 2 together in a solar charger, and I would hook these 2 together in 2 separate solar chargers, and I would just put it on 3 different solar chargers. There are some people that say, well, if they're going to get different shading, then everything should have its own charge controller. The reality is cost is a factor. Buying a charge controller for every single panel is the equivalent of buying the inline optimizers and stuff like that. And those things are just fine. So you have they have the microinverters and you have optimizers. You know, this is important that we understand the difference between the two, and that we know what the difference between an optimizer and a microinverter. A microinverter takes the power from the panel, goes through the microinverter, and it outputs AC power that matches the frequency of the grid and allows you to use that power in your house. And when you exceed the production of power in your house, then it sends that power back to the grid. It does need a basis of grid power for that to feed from to work. That is a microinverter. A optimizer would basically take the input of these 2 panels and independently take the power of them and convert that power and send that power off to your battery. And therefore the shade and the voltage of each of these would be kind of irrelevant. So that is the difference. It doesn't require a grid. It doesn't backfeed through the grid like that, and it would work a lot easier that way. So hopefully that clears up the question on that, and if anyone has a question about that, please just put it in the chat below. And I've got a couple of questions I'm going to get to, but I wanted to get to a couple more items here. That was mixing panels. We talked a little bit about that. Sizing your charge controllers, we talked about that. Panel voltage and inverter input requirements, we talked about that. We talked a little bit about roof and ground mounting, the pros and the cons. And we talked a little bit about how the panels measurements from the factories work. So that's very significant also. So now let's talk a little bit about some of the questions that we've seen. And I'm just going to go through these very quickly. And if anyone online has a question of their own, feel free to ask them. I have received some of these online in the last few days when I announced what the subject matter would be here, and I think I can turn them on like this. And the first one was John, and he asked, do solar panels work on cloudy days? And I've probably answered this 4 or 5 times in the past, and the answer is absolutely they do work on cloudy days. Do they work as well? No. It can be as bad as it was today, and I can actually show you today's performance and how bad the clouds was. We had rainstorms here, and it was just terrible storms and everything. So what I did is, let me just fix my screen real quick. There we go. All right. So what I did is, here is a live copy of my system as it runs right now. I do have an error here from one of my Bluetooth batteries going to my DIY battery. It doesn't seem to be wanting to read it right now. It does happen sometimes when Bluetooth interference comes in. I'm sitting at 54%, but as you can see from this chart over here, that's because I used the grid quite a bit today. Let's take a look at the power history, though. That's really what we were discussing here. So I'm going to go back into PV details. As you can see right now, I have about 19 amps of power coming in. I'm consuming about 5 amps out of the battery, so I'm not generating as much as I'm actually using. But it is very cloudy and rainy today. And as you can see from this chart, and this is today, and this is, yesterday was rainy too. You'll see that when you watch the video on it. Let me just go back a day. So here is a previous day here. You can see yesterday how bad the rain started here. So the production didn't go away completely, but it certainly took a huge hit. Now today's production, you can see here, it didn't take near as bad of a hit as it did over there. I mean, we're still generating 300, 400, 500 watts as opposed to the 14, 15, 16, 18, 1200 watts that we did while the sun was out. So did it take a hit? Yes, it did take a hit. 200 to 500 or 200 to 600 is somewhere between 20% and 50% of a generation. So it took a hit of 50 to 70% of the production vanished, but based on how many clouds, how bad it is, believe it or not, this is the second year that if you watched any of my videos from Connecticut, that I've gone to Connecticut and it's super overcast, and the solar system in the RV was generating more power than I could even use. I basically didn't go below 70% the entire time I was up there this year, and I was in that parking lot for a week. So they do generate that. So that's a very long-winded answer for a very short question that I probably could have answered in only a few seconds. But we will move on. How many panels would I need to power a small shed? Right now, I just built the solar shed. It's a perfect question. The solar shed video, the first video is out. The other 2 are in the bucket. And if you're a member, you got access to watch all 3 of them already. But I'm running it on 2. It depends on how big of a solar shed system you really want to be running. If you want to be running a huge solar shed where, a 48-volt system with lots of power, then you're going to need more solar panels. I had 3,000 watts of panels on the solar shed that was feeding the RV, and they two-thirds of them are vertical panels, and 4 of them are horizontal mounted on the roof of the shed. It generates between 6 and 7 kilowatt hours of power of energy every day. But the side panels, before I worked on the solar shed, you'll notice when you watch the solar shed video, I took them off and put them, angled them a little bit. And I did get an extra 1 to 1.5 kilowatt hours of energy out of them every day. So how much do you need? If you're just charging, like a lot of people just wanted a small 12-volt system to charge batteries and their lawnmower and that kind of thing, and to keep battery chargers and lights on, you can do it with a 12-volt system and a couple of 250-watt panels and easily run a system. You can also get into what I'm doing with the solar shed to feed the RV, where I'm getting 7, 8, 10 kilowatts a day and kilowatt hours of energy each day, and you would need much more. So it just depends on which ones what you want. I would suggest that the typical user in a solar shed is going to want to turn on lights, is going to want to run some basic drills. I ran, when I built the solar shed this weekend, I ran everything off of the solar shed power, and I was running saws and all kinds of stuff off of it, and I did a 3,000 watt inverter and a 12-volt system with 2 100 amp hour batteries, and it's running off 2 solar panels. 2 240 watt used solar panels is all it has. So hopefully that answers the question. How much does the average home solar system cost? Home solar system is the question there. And actually there are a lot of really good packaged solar systems out there. If you're interested in solar systems, in the link down below in my thing, I've got a link to Signature Solar. And that would be what I would suggest that you look at. But if we wanted to look at what some of them was, I can just show you quickly. A lot of, I like the off-grid systems. They have hybrid systems and grid-tied systems also. All of them can use the grid and just act as backup systems. And that's what I like, is for it to act as backup systems and to program it when, do that peak shaving and that kind of stuff. But how much are they? So kits and bundles is where you'd want to go and look. Where did it go? Inverters, kits and bundles, off-grid. I prefer these type of systems here, and they can range. If you're looking to get, a couple of to replace a large portion of your thing, you got a 6,000 dual 6,000 XPs here, which is 12,000 watts of power, which that would power a large portion of your home. And you're going to have 48-volt batteries. It looks like 4 of them, which is 20 kilowatt hours approximately. It's a 48-volt system with 12,000 watts of solar power. This is a decent size home system that leaves you room to grow in batteries and expand. And I would suggest that would probably be somewhere between the $10,000 and the $20,000 range. That doesn't include installation, and if you're doing it yourself, that's what it would look like. If you're not doing it yourself and you're looking at having a professional installed it, some of the kit like this would cost you more in the range of $50,000 to $60,000. The markup on installation is quite high, but they handle all your permitting and all that kind of stuff also. When you're doing an installation, in most jurisdictions, you can do the installation without permitting, short of panels on the house. And a lot of people now are referring to putting panels in rack mounts in the backyard or in the yards instead of on the house anyway. So hopefully that answers the question, and a little bit more. But do I need fuses and breakers between my panels and my inverter? And the answer to that is if you're running anything short of a single series, if you're running any parallel panels, then absolutely you do need. What you don't want is multiple series or multiple parallel panels feeding into one that is shorting off. You'll notice in the labels that come with it, I think I still have that label up here. If you'll notice in the label that comes with it, a lot of them will talk about the maximum fuse rating of where you should be fusing it in order to prevent influx of power. And what that basically means is they don't want you to have a fuse larger than 15 amps, because what could happen is that other panels, when this panel goes bad, could continuously feed this panel the electricity, even though technically the panel's not working anymore. Other panels would feed that short and cause it problems. So you keep that under 15 amps or under, and that prevents that problem. So yes, the answer is yes, you do need to fuse it in certain circumstances. But if you're running single series, or you're running not multiple parallels that aren't above the amp rating, then you can get away with not running them. And let's see, we're moving on now to, do bifacial solar panels make a big difference? The answer to that is they can, and it depends on how you mount them and how much reflective light you get from them. There's people who mount pergolas with concrete underneath them. There's people who are mounting the bifacial panels, the good 4 to 8 feet up off the ground with rocks behind them, or white backgrounds, or a white building behind them, and they're seeing some increases. Are they worth it? Recently, the bifacial panels prices have been better, and so I would say yes, so much so that even on my RV I installed bifacial panels. I seem to get a little bit of bifacial feed off of that from the RV, even though it's mounted flat on the roof, only a couple inches off. I think that's some of the light variations of light bleeding through. The bifacial panels don't have the paint across the back to stop all the light from coming through, and it allows the light to bleed through some of the seams, and I think that's where it's coming from. So do they make a big difference? I don't know about big. It depends on your definition of big. Do they make some difference? They definitely do. I think the average results I've seen from some of the tests that have been running is 8 to 10% in the right environment. Can I install solar panels without an inverter? Yes. I'm not sure what you would do with them. Some people can, if you have the right size solar panel. In the old days, we used to charge 12-volt batteries with solar panels that were rated for exactly the right charging rate of a 12-volt battery, and they would use that. Since then, we've gone to charge controllers because it's a lot safer, and the batteries are a lot more expensive and a lot smarter. So we don't do it anymore. But yes, it did happen. It did happen before, but I don't suggest it. Kevin from Ohio asked, do solar panels still work if the power grid goes out? This is a loaded question, Kevin. And the answer is if you have a system that is feeding the grid and you do not have batteries, you can pretty much count on the fact that it is not going to operate when the power goes out. If you have a battery system, then chances are it probably will. It's not a guarantee, but chances are it will. The difference here is when the electricity goes out, your system has to prevent the backfeed of power to the grid, which is why I like off-grid systems, because it allows me to supplement the power. It allows me to prevent that, but at no time am I feeding power back to the grid. In a house that I've got, then yes, in that case, I do grid feed, and I use the grid as a battery, and that is kind of why these off-grid systems, these house ones without batteries, were built. They use the grid kind of like a battery. When it first came out, it was if you generated a whole bunch of power during the day, you could feed it to the grid, and then at night when you didn't have power coming from your solar panels, you could pull that same power off the grid. Some locations still have that ability. Fortunately, here in Florida is one of them, but a lot of them have gone away from that, where they may give you a credit of 5 cents for every kilowatt hour of power or energy that you give to them, but then when you go to take that same energy back, then they charge you 12 cents, meaning you get an offset of 5 cents as opposed to getting the actual 12 cents. So it's a battery with a huge loss of efficiency, but at the same time, when the grid goes down, you don't want to electrocute the guy trying to fix it. So they force you to have them shut off. So yes and no, it depends on the system. Um, what happens to old solar panels when they wear out? And I guess the question becomes is there is a lot of chemicals and stuff within them that will need to be recycled, and that's why a lot of these solar where these what do you want to call them, when they upgrade these solar fields and these solar farms, why they sell the panels so cheap, because selling the panels cheap and having people come pick them up in bulk is a whole lot easier than paying for the recycling or the disposal of the panels. There are a lot of different chemicals and stuff within them, and you'll see some proponents of solar argue that the energy that it takes to build the panels and the waste of the panels after the fact isn't worth it. To be honest with you, long-term effects, I don't know. I do know that solar panel degradation is between 0.5% and 1% per year, meaning that most of these panels are going to be around for 20, 30 years, even if they're only used in partially after the fact. So the answer is, do they when they wear out, is a very long time in the future, and a lot of energy can be generated in the time, and I guess it depends on how well that's used and how well that's done. Do solar panels make your roof hotter or colder? It's a very interesting question, and the short answer is it makes it cooler. It protects it from getting hit by the sun, and it provides a barrier for that heat to be dissipated between the panel and the house. If your panels are actually laying on a roof, then no. It can help, it will tend to make it worse, and it's kind of like when they're laying on the thing and they can't breathe, then you do get that same thing as if you don't have breathing vents in your attic. So you do want to have them mounted up off the roof a little bit, at least to give them breathe, but it does make it cooler. Do the microinverters compare to string inverters? How do microinverters compare to string inverters? It's very simple. A microinverter takes one solar panel and converts it to AC power to feed into your power system and for your consumption and feedback to a grid. They match the frequency of the grid, so when the grid goes out, the inverter shuts off, thus giving the power company what they want is a system that shuts down. A string inverter will take a string of multiple panels and pull them all together and do basically the same thing. Usually microinverters are a single panel comes in, a single panel is fed out. A string of inverters can take a string of 4 or 5 or 2 or 10 and do the same thing. But it is a much larger microinverter as opposed to a true microinverter of a 200 or 300 or 400 watts. How much power do you really lose from shading? You can lose quite a bit. If your panels are set up in series and you have older, especially if you have older panels, when that one panel gets shaded, those diodes cut that electricity off. It cuts off the whole thing, and you will lose most of your panels there. So it can be very significant if you're not paying attention to when we talked about this earlier about your parallel and series of panels and how to configure them. And I am going very quickly through these questions. If you have a question or you have some comments on one of them, feel free to put it in the comments. It's not a problem. I'll be glad to answer any questions. Can I add more solar panels later to expand my system? There are a lot of companies that will build the system, as we talked about earlier, based on the size of your inverter, and the answer then becomes no, not without some changes to the rest of the equipment in your system. The answer should always be yes. If you're purchasing a system from somebody, you should be able to add more batteries, you should be able to add more panels, you should be able to add more. Most DIY solar systems are built with the idea of expanding in the future. Does that mean that if you pay someone to build you a system and to put it into your house? For example, I had a home system that was installed in a house that I've got. It's got a 10,000 watt inverter, and it has 12,500 watts in panels. That means that there are times during the day where it generates in that open window that we discussed in this chart here, where we extend that time of where the where it can get the maximum amount of power out of those panels, and it clips off the stuff over top of that. But that so in that case, it wouldn't be beneficial to add more panels, and there may not be inputs of it. But in most systems, if you're getting one installed, those are questions you should be asking, and you should be saying, well, what if I want to make this bigger? What if I want to go further off grid? What if I want to increase my usage? How can I expand this? And what can I do to solve that problem? So the answer is yes, it should, but not all installers are after doing what's best for you. They're after getting what they can out of you. And unfortunately, it gives the whole industry a bad name. How do I mount panels on a metal roof? Actually, metal roof panel mounting is probably one of the best there is. The clips and the mounts that they sell for metal roofs are fantastic. But that said, let me just see if I can find metal roof types. And so let me just show you what you have to deal with when you're dealing with metal roofs. As you can see here, there are a variety of metal roofs. You've got beaded ribs, you've got V-ribs, you've got straighted ribs, you've got flat ribs, you've got clip ribs, you've got pencil ribs. There are tons and tons of different copper roofs, zinc roofs. When you talk metal roofs, it's like saying, you know, I want a coffee. There's 1,000 different types of coffee. There's also 1,000 different types of metal roof. The corrugated ones they sell clips for, the sanding steams, the stated, there are just tons of them here. Most of them have some really good mounts that can go on them, and I think it's this one here. Whoops, I just clicked on the wrong link. I think it is this stranding seam that has the best mounts. It requires no holes in your roof, and you just clip them on the side. The clips go right on and hold the panels. They're easy to move around later to expand and disband. So the answer to your question is, how do I mount panels on a metal roof? The answer is, get the right mounting clips to go for your particular type of metal roof, and most of the metal roof clips are better than the shingle ones, and it actually works out better and is much more expandable and workable in the future too. So then we go on to, do solar panels increase home value? Now, this is a loaded question, and there's a lot of bad misinformation on this, and this is actually a trap that I fell into. So if there are a lot of companies out there that are doing, you know, they rent you the panels and they put them on your house. They make it very difficult for you to sell. They make it to where people have to assume leases and stuff like that. I'm going to get a little into an opinion here, and have gone through this a couple of times and want to make it very clear. You should never lease, rent, or anything panels, and you should probably not really finance them either. I understand that a lot of us can't get out and do the installation ourselves. So I wouldn't say that you shouldn't pay someone to install them, but I think that you should consider the possibility of the difficulty of doing them. For me, it was getting a $60,000 solar system installed on a house. You have a 0.5% loan that they're going to give it to you. And they're giving you the 0.5% loan because they've baked in a lot of the cost up front for that loan, and regardless of when you pay it out. Now, it's got a 25-year payout, so your payments are very low. They cover your electricity cost, and the solar panels' life expectancy is 20, 25 years. And the equipment's warranted for 10 years. So overall, it's a great deal. The problem comes when you decide to try to sell your house. Do they increase the value? People do not understand that you're paying for, you know, a $200 solar loan every month, and your electric bill would have been $300 or $400. I can tell you firsthand, Right now, I have a house on the market that has that same exact problem. And sadly, people don't have enough foresight to see, well, if I'm assuming another $50,000 loan, then the house isn't worth an extra $50,000. And my answer, the real answer to that is no, but you don't have that $400 electric bill either. I have not seen an electric bill over the $29 flat fee that's charged, the base fee that Florida charges for electric since I had my solar installed years ago. But it does make it very difficult to sell when the time comes for that. So do they increase the value of your home is the question. The answer is yes, they do increase the value of the home, but it is very much like a pool. If you finance a brand new swimming pool and you put that pool in a 10-year loan and then 5 years later you go to sell your house, nobody's going to want to pay that loan to get the house. They just want the increase in value. So then you have to pay off the loan, and because you have to pay off the loan, people discount the value of the loan. A lot of this is best seen from financiers when you go to get a mortgage and they ask and you show them that you have this $50,000 loan on the house, and they don't count it in the appraisal of the house until the loan is paid off. So my best advice is, yes, you should get the solar, but you should estimate the value of the increase at probably 20 or 30% of the value of what you're going to spend on the solar system, and it needs to be paid off for that to take place. So you need to make that money back before you're going to consider it, is kind of what I'm saying here. And I know that was kind of a loaded answer. It does increase it, and if it's a small one and it's paid off and up front, then absolutely it increases the value of the house, and in the meantime you get the savings along with it, and all of that comes with owning solar. But I would suggest that you go with a battery-based off-grid type backup system that works when the power goes out, and that will increase the value much more than the existing solar systems that a lot of these companies are installing for you at this point. A lot of that is preference, a lot of that is personal experience, and a little of that is bitterness from why we look at things the way we look at them when it comes to solar sometimes. What is the efficiency difference between new panels and old ones? It is the efficiency drop is between 0.5% and 1% per year. That is one of the most misconceptions in the industry, is that solar panels age and they lose a lot of their efficiency. A 20-year-old panel shouldn't have more than a 10% degradation in power. Now, I say that the panel won't have more than 10%, shouldn't have more than 10. That doesn't mean that you're not going to have to replace the connectors on the panels. That doesn't mean that the wires that are on there didn't get sun-baked for 20 years and are rotten and need to be replaced. The panel itself, not the wires and connectors and stuff like that. Those, you need to do regular inspections, you need to check them, you need to replace them. And a lot of the times when I buy used solar panels, the first thing I do is cut off all the connectors and put new ones on there, because that's where the inefficiencies are coming from. So what is the efficiency difference between new panels and old panels? About 0.5 to 1% per year is where it should be. If it's any more than that, your old panel has probably got something else wrong with it. How much maintenance do solar panels need? They do require some maintenance as far as watching, and it depends on the complexity of your system. I've got a home system that's on the roof where the company that installed it, the one we were just talking about, and they call me once a year or so and say, hey, we see that this micro inverter went out and we've got to come out and replace it. I'm like, okay, go replace it. If it's a DIY system, and depending on what the quality of the way you hid the cables and the way you routed them and stuff like that, you'll see that sometimes you're going to need to replace some connectors. I personally, about once every couple of months, just because I'm in the business and playing with them all the time, I like to take the thermal camera and take a look at all my different connectors and make sure that they're not aging prematurely and that they're not hot. And the ones that are hot and having problems, I have a tendency to cut them off and put new ones on. So what kind of maintenance does it require? Inspection, review, and kind of watching them to make sure that they aren't going south. If you see a big loss in power, I had a friend of mine that just a few months ago, says, "Can you help me? My panels are out." And I'm like, "What do you mean your panels are out?" She's like, "Well, they don't work anymore." And I'm like, "What do you mean they don't work anymore?" She shows me the app, and she pulls up her app, and they're all reporting 0. And so I go out to her panel. I said, "Sure, I'll take a look. I don't know what you've got and everything." It was a new house that she bought. And she's all panicked and saying, all of a sudden she started getting an electric bill back a few months ago, and she didn't know why. And so I start looking at the system, and it looked like that she's right. Oh, the system had just shut down, and it wasn't reporting. So there's a phone number on it, and there was a warranty that came with it, and so on and so forth. And unfortunately for her, the company that was honoring the warranty was gone. And that's one thing you've got to be very careful about, is that you get a very reputable company. But the company was out of business and doesn't answer, the emails bounce back and stuff like that. It was very sad. So I said, okay, well, let me take a look at it. And I go into the system, and I put a voltmeter on a couple of the different things. And it's a micro inverter system running, I think it was 12 panels, and eliminated a good 80% of her electric bill. So she's getting $200 electric bills, and that where she was used to $40 electric bills. So I take the system, I open up the bays, and they've got a bunch of breakers and everything. So my thought is let's just take the same mentality I would take if this was my system. Let's just shut the whole thing down and reboot it and bring it back up. So I shut the whole thing down, and I boot it back up, and I see some of the lights come back on. It goes back right to the same way it was before. And I tell her, I'm sorry, we're going to have to figure out, another time. I was heading out of town, and we'll figure it out. And she calls me back a week later and says everything's working again, and that her electric bill is gone again. So what kind of maintenance do the panels need? They do need some maintenance. In that case, they needed it. Someone was supposed to be monitoring them, and just probably a simple reset from a central office would have solved it. In my case, I was able to flip the switches and turn them off. The cables sometimes get sunbaked, they get old, or the connectors go bad, and those type of things can be dangerous. So it does require some maintenance. But that's going to be required regardless if you pay a company to do it or you do it yourself. They are not maintenance free. You do need some basic monitoring. As you see here, I use Home Assistant for my automation tools, but it also gives me a lot of information about my PV input. And you can see here, on all of these stats around here, the voltage that's coming in from the solar shed on the right, where it says PV3, the 2 set series of panels on the roof, and the amount of wattage coming in. I can also go in and say, okay, show me the energy input that I've gotten from the system. Today I got 12.8 kilowatt hours, and the grid 21 kilowatt hours. It's just killing me. It was raining, my batteries were dead. They switched over to using grid last night, and I had them set for us being out of town, where they just use what they basically have to use in order to wait for the sun to come back up. And then I realized we had to do laundry, and I needed some power, so I told it to charge for a little while. But so you need to watch these type of things to make sure that you understand what's going on with them. And I've been using so much grid lately; it's just ridiculous. But so that's what I do to monitor them. What do they require? Well, a lot of the times they're hands off most of the time. You don't really need to do it all the time, but I do, because that's that's what my channel is about watching them and monitoring them and doing these type of things. So for everyone else, it's not as important, but I do catch myself from time to time. I go days without even looking at them. So can solar panels power an electric car directly? I don't know the answer to that, and I don't think I would even try it. I did see one on YouTube somewhere where I think the guy, but my guess is those were going through charge controllers and going directly into a 48-volt battery, because a lot of those cars are 48-volt battery, and so it was just burning the electric power out of compensating for what the battery had there and what excess was going into the battery, and anything below that was going. I don't know the answer to the question. It's technology of cars is a little bit different. The batteries are not quite as safe as the lithium iron phosphate that are used for solar, so I don't mess with the car batteries very often. Can DC coupled solar systems be more efficient than AC coupled systems? Yes and no. The AC, they're all, the panels are all being converted, whether they're coupled or not. Yeah, I don't know if they can be more efficient or not. It depends on how much power you're using and what the exact use case would be. That's a really hard question to answer without really knowing more details about exactly what you meant by what kind of DC coupled system. Are you talking about multiple coupled chargers and those are feeding into the same battery bank? Or are you talking about AC coupled, meaning, you know, multiple inverters feeding the same breaker boxes and stuff like that? I'm not sure exactly where we're going with this, but I'm supposing you can build the efficiency in anywhere, one better than the other, depending on what you're doing. Micro inverters and all that kind of stuff can handle a lot of that coupled stuff too. So what happens if a panel gets shaded by a tree or chimney? For the most part, it destroys a lot of its production. It can also, in a series of panels, so if you've got, we can take this one really quickly here over to the whiteboard. So if you've got a series of panels where you're hooking up, you know, 4 panels in series, let's say. And what I mean by series is you're taking the negatives to the positive to the negative of each one, and you're running the power out of it like this. And you're taking the voltage of each of these, and it's aggregating them together and giving you one output here. And that means that if this one gets shaded, and let's just say that, you know, a big shade tree comes over and covers this one, it will destroy the power of all of them in that series. They do have some new panels that are fancy and that'll only destroy part of it. And some of these panels are split in half now, have splits or split 4 ways or 2 ways. But for the most part, that type of feed is going to impact your entire string. It won't affect, a lot of times it won't affect the other parallel panels to this string, but it will affect every panel in that string, depending on the age of your panels, the type of your panels, and how many splits they have, and how they divide up. And I'm sure the technology will continue to get there. And basically what you're basically doing is building a bunch of smaller panels into one bigger panel and having all that electricity in here. I'm not sure long-term if that added complexity with built into the panel won't backfire more than it's building diodes and all that into this. It's just that one more thing to go wrong on the panels. And I think what we'll find is that in the long run, these panels that have this extra efficiency in it, we're going to pay for it in the fact that these panels are going to break down, and you're not going to be able to get into the actual internal of this panel and replace that little tiny built-in diodes along the panel runs inside this circuit board. And so we're going to end up losing efficiency that way, and it's going to cost us more than just having avoiding the trees by serial and paralleling them in the correct way. So, but that's my opinion. I have no evidence to back that up at this point. So what happens when one gets shaded? That panel goes down, and all the panels in that series usually go down also. Next one is, what is the highest efficiency solar panel available today? I have no idea. Solar panel efficiency sounds like a question for ChatGPT to me. Let's just see what ChatGPT, what is the highest, this will be interesting to see what it thinks. Highest efficiency solar panel available today. All right, so what does it say? It says as of 2025, it looks like it's achieved 24.9% module aperture efficiency, validated by US INRAD. Oh, Wow, 24.9. That's pretty good. This panel has 25.4, achieved 25%. So it looks like right at about 24, 25% is the highest efficiency. Was a much better answer from ChatGPT than I was actually expecting, to be honest with you. Uh, I was expecting it to find the first panel it could on the internet and report 18.2, but that's not what it did. So looks like about 25%. My guess is you're going to pay a premium for it at this point, though. How do net metering, how does net metering program work with solar panels? This is actually a really good question, and I'll briefly go over it when we'll use the whiteboard to do it. So net metering is pretty simple. Net metering is, for all practical purposes, you're using the grid as a battery. So let's say you have a solar system here where you have some panels. It doesn't matter how many of them or how much power it generates. And this feeds into your inverter. Now, this can be an actual inverter. This can be microinverters. This can be string inverters. This can be, basically, you're taking the power from its DC side, which is up here. Let's just do it this way. This is all DC power. And it goes through the inverter and comes out as AC power. And that AC power is fed into your house. Now, what power you use in your house, let's say you hook up your refrigerator and you use, let's say we generate 1,000 watts here, and you use 200 watts from your refrigerator. That means you have an excess of 800 watts of power. And what would happen in a net metering situation is this 800 watts would be fed back to the grid backwards in your meter. So instead of you taking power from the grid, you're going to put that power back in the grid. Now, later on in the day, when the sun goes down and you're generating, let's say 100 watts, but your refrigerator is still running and needs 200, it's going to pull from this power that it put on the grid and use it there. Now, net metering is a very complicated question, because a lot of people will ask, well, if it's 1 for 1, and that's great because you get to use this as a battery. It is very rarely 1 for 1, meaning you put in 100% and you may get back 90%. You may get back 10%. And why are you going to get back that percentage? It's not an efficiency drop. If you give the power, let's say you give 100 kilowatt hours of power, of energy to the 100 kilowatt hours of energy to the power, to the grid, your electric company has a net zero net metering agreement with you. They're going to pay you a certain amount for each of those kilowatt hours, and then they're going to charge you a different rate for you getting power from them. So you may give them 100 at, let's say, 5 cents a kilowatt, and they may charge you 15 cents a kilowatt, meaning you're only going to be paying 10 cents a kilowatt to get that power back that you gave them. There are some of us that are in a very, very unique situation, some places here in Florida, where if I give you 100, I can get back 100 at full value. Very cool. But very few do it that way. Most likely, what most of them are doing now is they'll give you, during their input peak time, they'll give you the 6 or 8 cents a kilowatt hour. And then when you need that power at 7 o'clock at night at peak time, they're going to charge you 80 cents a kilowatt hour. And so that's where net metering can backfire on you. But the sense is what is it And how does it work? Is think of it as a battery. You put power into the battery and you take power back out of the battery. And that's what net metering is, meaning it's the net of what you use versus what you give them that you pay for. Meaning, now, you're not going to, like I said, it's not usually a one-to-one. So keep in mind that net metering doesn't necessarily mean kilowatt hours. It could mean dollars, what it's worth to them to get it versus what it's worth to them to give it. So that's what net metering basically means, and I hope that makes sense. And if anyone online sees anything aspect of that that I missed, please let me know. I'll go back and revisit any aspect of it I need to. Do I need special wiring for solar panels? Yes, solar panel PV wiring, and let's just go out and take a look at, we'll just do that on Amazon. What do you say? You can actually look up on Amazon solar PV wire. And they sell it in multiple sizes, but there is a difference between PV wire. It has a good, better, thicker insulation. It's also made to handle more harsh weather, being out in the sun. It's not invincible, but it is basically made to take a little bit more outside type environments. Now, it is also comes in different sizes, just like any other wire. So you don't want to discount the fact that this is a 10 gauge 30 amp wire, meaning that you can't transmit more than 30 amps down this 10 gauge wire. And you should also take in code regulation on this and leave a 20% buffer, meaning that you shouldn't use more than this for more than 24 amps of PV. And then you should go to a smaller wire if you want to, smaller gauge wire, meaning a larger sized wire, if you need to do more than that. But, so there is 12 gauge also, I believe. Let's just see if it's in here. Yeah, there it is, 12 gauge. So, but there definitely is difference between, so 12 gauge, that's 10 gauge, that's 10 gauge. I look for 12 gauge, it doesn't.